This is the story of how Tata Motors raced against time.
If you take longer time, by the time you introduce your vehicle, it will be irrelevant.
And innovated to build an EV in India, for India.
This is such a beautiful thing to be able to create electric vehicle within India.
The future is going to be quite exciting, quite bright.
Energy powers the world. It shapes the way we work, play, and move. But energy generated from fossil fuels is warming our planet. And humanity is feeling the heat.
Climate change is so real now that the evidence is all around us, and we are facing it, experiencing it all the time. With untimely rains, extreme weather events, the frequency, intensity of the extreme weather events. If you look at the Arabian Sea and the Bay of Bengal, the surface sea level temperature is actually rising more than the global average. And if that continues, we are going to see these extreme storms, extreme cyclones in the future.
In 2016, India ratified the Paris Agreement, an international treaty that aims to limit global warming to well below 2 degrees when compared to pre-industrial levels.
Climate change is coming to us at an enormous social and economic cost. It is chipping away our GDP, and we cannot look away from this change anymore.
In 2020, a study estimated that the economic losses due to air pollution in Delhi were more than rupees 50,000 crores. Burning fossil fuels is also choking our air. India is home to 13 out of the 15 most polluted cities in the world.
That's the reason why we have to convert each and every tailpipe into a zero-emission tailpipe. And that can be done only with an electric, battery-operated vehicle.
The basic technology for electric vehicles have been around for over a century. But in comparison to internal combustion engines, battery capacity put a limit on how far an electric vehicle could be driven. At the turn of the century, the assembly lines of Ford Model T reduced the cost of gasoline-powered automobiles. Refueling of gasoline cars was a breeze when compared to electric vehicles, which became niche, experimental products. However, over the last decade, a perfect storm has been brewing around electric vehicles. Batteries grew more powerful, which made the cars go faster and further, and they started getting cheaper. In 2010, there were just 17,000 electric cars on world roads. By 2019, the number ballooned to 7.2 million. Electric vehicles were on a path to widespread adoption. Initially, India lagged behind the world. Few electric vehicles were manufactured. The Indian consumer's response? Lukewarm. In 2015, in a major policy push, the Indian government made electric vehicles cheaper to produce and buy. In addition, the scheme laid out a roadmap to boost charging infrastructure for electric vehicles in the country. In 2016, the government tightened the emission norms of vehicles. It announced that all petrol, diesel and CNG vehicles sold after 2020 would need to be compliant with Bharat Stage 6 norms.
The jump from BS4 to BS6 actually had a huge impact.
For automakers and consumers, it meant a big jump in costs.
It was very clear to us that migration from BS4 to BS6 is actually going to increase the cost of the vehicle significantly.
India was now primed to switch to electric vehicles. In 2017-18, Tata Motors, one of India's homegrown auto companies, decided to bring to market an electric vehicle that would take its place next to existing petrol-diesel vehicles. Pimpri Chinchwad, an industrial township 15 kilometers from Pune, home to Tata Motors' mega manufacturing facility. Spread over 228 acres, it can produce 225,000 cars and SUVs every year. But building an electric vehicle was a different ballgame.
For the first time, we were developing a high voltage electric vehicle, and therefore our experience curve was not mature.
That's why Tata Motors decided to convert an existing vehicle from their stable to an EV, instead of building one from scratch. But which car? Tata Motors commissioned a survey, codenamed Project Mango, to arrive at an answer. When the results were analyzed, three key concerns emerged, and only one car could address all three: the best-selling Nexon. First, the performance.
EVs in the country have not been seen as aspirational vehicles in the past. And if we have to make EVs a mainstream choice for the consumers in India, it has to ensure that it is aspirational in terms of performance.
This would mean a large, powerful engine and a stable body to support it. Second, the range. This is the distance an EV could travel on a single charge.
The earlier EVs, they had small battery packs, so they were essentially city cars. They did not have much range. I needed a car which gives me a range of at least 220 kilometers.
This meant bundling in a high-capacity battery. Since this would be fitted to the car's floor, Tata Motors needed to choose a vehicle with good ground clearance. Third, safety.
The base Nexon had a very, very strong image of being an extremely safe product. It was already a 5-star product at that point of time.
The team now had a firm direction. Success would hinge on not just how good the car was, but also how soon it would hit the market. Competitors were readying their own foray into the EV sector.
Tata Motors had taken a bet on electrification. And therefore, it was essential that now we move fast and become the first mover.
So when Tata Motors launched the Nexon EV, well, clearly I think, they just leapfrogged ahead of the competition.
The move was logical but risky.
Accelerating the adoption of EVs in India is not only about producing and developing vehicles. It is also about creating the entire ecosystem which breaks the barriers that exist towards adoption of EVs.
Tata Motors decided to draw an expertise within the Tata Group to address these barriers head-on. From creating electric vehicles that struck a balance between price and performance, to developing battery technology, setting up charging infrastructure, and offering financial solutions.
Tata Universe is a concept and a unique platform of proactively collaborating within the Tata Group, which has the benefit of having different domain expertise to create the EV ecosystem and accelerate the journey of electrification in the country.
But this strategy depended on the first high-voltage electric vehicle to come out of the Tata Motors stable. The team developing the Nexon EV was given just 12 to 16 months to bring the car to the market. Fast-evolving technologies like electric vehicles need agile development.
If you take longer time, by the time you introduce your vehicle, it will be irrelevant. And therefore, it was important for us to have a very agile development model so that in this rapidly changing technology world, we always are relevant when we introduce our products.
The big question, however, was, could the Tata Motors team deliver an electric vehicle in the tight timeline? how would they do it? EVs are the future of mobility in India. In a bid to shape this future, Tata Motors decided to convert the Nexon into an EV in 2018. The team had just 12 to 16 months to deliver the vehicle.
Impossible. How do you achieve it? That was my first reaction.
Developing a car is a complex process. It requires intricate coordination within departments and component suppliers, local and global. A conversion project like this takes up to 30 months to execute. The team at Tata Motors had only about half that time.
Every supplier we talked to, they said, "Excuse me? How long did you just say? You're missing years off your mark."
None of us knew what would be the challenges. The only good thing was that this was being built on a common platform.
The process of manufacturing the Nexon EV starts at Tata Motors' massive manufacturing facility at Pimpri Chinchwad near Pune. Sheets of steel are first molded into the building blocks of the vehicle, such as the roofs, floors, frames, and doors. Once shaped, they make their way through the weld shop, where automated robots use laser welding with synchronized precision. The framing and metal finishing lines are where the parts come together. These metallic shells are called body in white, or BIWs. For the paint, the BIWs travel 60 kilometers to the paint and trim shop in Ranjangaon. Tata Motors Design Lab created a unique color for the EV line.
The teal was an interesting shade for us because we didn't want to be cliched. We didn't want it to say green because that's such an overt message. But it's a very unique color which has become a brand color for all our EVs.
The freshly painted shells are buffed to smoothen the finish and sent to the trim line. Here the cars get their lights, windshields, bumpers, and axles. The design lab also created a signature color called EV Blue for the accents. There are EV Blue elements inside the vehicle, on the dashboard, multi-information display, center console panel, and the stitching on seat covers.
The first generation Nexon was a friendly car, an easy, affable, friendly, inviting sort of vehicle. It's now confident.
Next, two key power elements are fixed to the electric vehicle: the onboard charger and high voltage cables to distribute electrical energy from the battery to the motor and cooling systems. These electrical components arrive at the Ranjangaon facility from Aptiv's plant near Pune. When Tata Motors approached Aptiv in 2018 to supply electrical components, the company did not have manufacturing lines to build them in India. At the time, there was virtually no product like Nexon EV in India.
Democratizing any technology, whether it's traditional internal combustion engines or electric vehicles, requires scale, requires volume.
Tata Motors wanted certain parts to be manufactured in India in order to bring costs down and help the Nexon EV qualify for incentives under the Indian government's FAME scheme.
Back then in 2018, nobody was believing whether the customers are going to accept electric vehicle. On the top of it, when we were also asking our suppliers to not only supply but also localize them and invest in India was another big challenge.
Building new manufacturing lines is expensive.
There was a lot of questions about Indian consumption of electric vehicles.
Suppliers wanted to understand from Tata Motors the potential size of the market for electric vehicles before agreeing to localize production.
In my trade, we're used to just the buying aspect of managing the supply base, but here we are. We're actually trying to convince people of the potential. We have to do that.
When they do this, it helps us to bring that new technology in India, and also it helps us to bring the cost down. So we got our global experts, people from our German office, people from China office, they came up here and then they helped us setting up the line, designing the line.
These manufacturing lines at Aptiv build and test the high voltage wiring and charging components.
Safety is very important. So we do a testing at 3000 volts.
After passing quality checks, the components are dispatched to Ranjangaon to be fitted on to Nexon EVs. Next, the EVs are fitted with their suspension and tires. At this stage, the vehicles are called gliders, which are ready for the battery and powertrain. The gliders are sent to K-Block at Tata Motors' main manufacturing facility in Pune. The battery and powertrain set electric vehicles, or EVs, apart from fuel-based vehicles. In an EV, instead of a mechanical engine, an electric motor powers the vehicle. Instead of burning fuel, a battery supplies the energy. The powertrain assembly begins with installing the motor on the EV.
Performance was another area of worry for the consumers who always were of the notion that electric vehicles are sluggish as compared to IC engine vehicles, and therefore there is a compromise that they have to make. We just did the opposite. We said that the performance of EVs under the Ziptron technology is going to be much superior, peppier, and higher on power as compared to an equivalent IC engine vehicle.
The 95 kilowatt motor that we have today was a ready-made off-the-shelf motor, and we picked it up to make sure that it was integrated well.
On the assembly line, the motor is fitted on the cradle. On this are mounted the onboard charger, DC to DC converter, and power distribution unit. Wiring harnesses are fitted to direct power across the vehicle. The motor and cradle unit is fitted to the glider. When powered, the motor delivers instant torque. The company claims the Nexon EV accelerates from 0 to 100 in less than 10 seconds. But to do that, it needs a powerful battery that's critical to Nexon EV's performance. How did the team design a battery? And could they develop it within the tight timeline? Manufacturing the Nexon EV involves a choreographed sequence of steps. After molding, welding, painting and fitments, it's now time to give the EV its heart, the battery.
So battery is the heart of the electric vehicle. We wanted to make sure that we offer the maximum possible range.
Range was a big area of anxiety for the customers. And when we did a survey of the customers, what will be a comfortable range for them? And we came to know that customers were looking for minimum 200 kilometers of range. So under Ziptron, we promised to give a certified range of minimum 250 kilometers.
Which meant that by rough calculations, we needed to have about 30 kilowatt of energy underneath the car.
The battery would take significant space within the car, add weight, and determine two key consumer concerns: the range and the cost of the EV. It would also take time to develop. But time was one thing the team didn't have.
We actually looked at the holistic timing plan and said, how do you actually compress it by actually doing things in parallel?
The Nexon EV team was kept lean. All team members were relocated to Pune. The core team would gather together every day for stand-in meetings.
The importance of daily work management meetings is significant because it enables that all the stakeholders who are identifying various aspects of the program come together at one place and they resolve all the issues by looking at how does that particular issue affect some other work stream or some other function.
Iterations of the design were carried on computer-aided design or CAD platforms. The team ran simulations to understand questions like how big would the battery be and how would it fit under the car, or how a design change in the battery would impact the driving dynamics of the vehicle. This accelerated the development process.
And by the time our first prototypes were ready, we were already sure of what the car was going to deliver to us.
Engineers on the manufacturing line wanted to know how the battery would fit onto the actual vehicle. But the battery wasn't ready. SIVA blocks, a material used for construction, were used to create a model of the battery that matched the digital designs.
We were trying to make changes to the production line even before the first battery was available in physical form, and to see how the battery would get fitted and what would be the problems associated with it.
The battery on the Nexon EV is designed to fit on the vehicle's floor. The 230 kilo of weight it adds to the vehicle's frame gets distributed equally between the front and the back, enhancing the vehicle's traction and handling. Even as the battery prototypes got ready, Tata Auto Components, or TACO, was brought in to manufacture them at scale. And carry out the necessary performance, durability, and safety tests. The battery pack contains lithium-ion cells packed into modules. Every module is also fitted with cooling lines
Inclusion of liquid cooling within the battery for a hot weather country like India is super important.
Batteries lose their efficiency in extreme temperatures. Ambient temperatures during summers can go beyond 50 degrees in states like Rajasthan. Batteries also generate heat while charging or discharging, so they need to be kept cool at a temperature where they work most efficiently.
And if the performance of the car has to be maintained even under those conditions, the battery liquid cooling enables us to meet the performance as well as the life durability expectations.
The Project Mango survey had revealed customer anxiety about driving an electric vehicle on wet Indian roads.
And it was very important for us to allay people's fears of an electrical system being inside water or in contact with water. People had fears about whether it would mean some electric current passage to them and harming them.
The solution was to seal the battery against water, humidity, and dust, and get it an IP67 rating. This rating certifies that the battery can be immersed in water up to 1 meter deep for half an hour without water getting into the battery. Tata Motors is so confident about the battery, it offers 8 years warranty on the battery pack. Water and temperature are not the only stress for a battery. At the design stage, battery prototypes were subjected to an array of tests.
These are the tests which actually test the battery pack under entire adverse conditions of typical Indian road conditions, the potholes, the bumps, in fact the off-road conditions which a vehicle undergoes.
In all, 45 tests were conducted on the batteries during the development stage. A lift raises the battery to the vehicle floor. Workers now attach low voltage, high voltage, and earthing wires to the battery. Coolant connections are made. And finally, a fuse is attached to the battery pack. The battery is now powered up, and the car is tested for roadworthiness. A wheel alignment test to ensure a smoother ride. Roll and brake to check brake performance. A shower test where the EV is sprayed with water at 1.8 bars of pressure for 9 minutes. This is to ensure there is no water leakage inside the cabin. Finally, the quality assurance team ensures every tiny detail of the car is up to the mark. A total of 12 tests are carried out on every Nexon EV that rolls off the factory. Today, 70 Nexon EVs roll off the line like clockwork. The facility has a capacity to produce 10,000 EVs per year. The team had used innovative engineering to build the Nexon EV in a short duration. But before moving forward, the prototypes were put through a series of tests to measure their performance and safety. Starting with the crash test.
I'm ready for launch. Please give the clearance. Okay, launch.
The 30 kilowatt-hour battery on board the Nexon EV added over 200 kilos of weight and electric charge. This would have critical implications.
If something were to go wrong in terms of a short circuit, for every one crash that we do in the physical domain, there are hundreds of simulations that we do in the computer.
The simulations help the team prepare for physical tests. The company claims Nexon EV's safety features have been modified, reinforced to ensure passenger safety. The car was then exposed to the elements. In the hot chamber, the EV performance is measured as the temperature is cranked up to 50 degrees Celsius. In the cold chamber, battery charging and performance of electrical components are measured in sub-freezing conditions. In the water wading test, the car was driven into water to test the IP67 rating on the battery. The car may brave the elements, but can it take on the stresses of Indian roads? The four-poster test simulates the harsh road conditions the suspension will encounter. The EV is driven on a torture track to fine-tune suspension and ride comfort. And then driven up a ramp to test if the car has enough juice to climb steep inclines. It is tested in the anechoic chamber, a room built to block out all external sounds. In absolute silence, the minutest sounds get magnified. Engineers study these sounds and fix parts responsible for it. Tweaked and strengthened, the car was ready to hit the Indian market.
And actually, it had fantastic performance. It became something which really opened people's eyes to not only the convenience and the economy that's expected from an EV, but even the fun to drive factor which they offer.
The Nexon EV was only part of the offering. Tata Motors wanted to deliver a smooth customer experience. That meant building charging solutions for home and public places. Tata Motors is on a mission to help India evolve to electric. In a nascent market like India, the Nexon EV would introduce many consumers to the very concept of an electric vehicle. That's why it was crucial for the company to deliver an effective charging experience. That's where Tata Power, an integral part of the Tata universe, stepped in. Tata Power and Tata Motors developed two charging solutions. Fast chargers recharge the battery from 0 to 80% in just 60 minutes. These are set up in public spaces and along highways. A home charging solution is bundled with all Nexon EVs and set up in the customer's home or office.
Full charge at your home takes somewhat like 8 to 10 hours, so you can conveniently leave it overnight at your place, and you can track the progress of the charging by the Z Connect.
The Z Connect app also helps customers locate charging stations in public places and highways, and to make payment for using the fast charger. Reports estimate that there will be 2 million EVs on Indian roads by 2026. These EVs will need 4 lakh public chargers. At present, there are less than 2,000. That means charging infrastructure needs to grow around 200 times in just 5 years. Tata Motors and Tata Power work together to install chargers in public places, within cities and along highways.
We work very closely with Tata Motors on this. We start identifying potential locations, housing colonies, complexes, and also the public locations where potentially we can go and put the charger. And we ensure that by the time the dealers start selling the vehicle, we are very much on ground and are able to cater to the requirements. We also identified coffee shops, dhabas, food courts which were there between the cities, and tied up with them to ensure that when people go to these locations, during the period that they are having the food items over there, they can charge their vehicles also.
I generally work between factories, so it's generally Jalandhar, Narwana, and some few cities in Delhi NCR area. So my daily average kilometers came down to about 200 to 180 kilometers. Tata के chargers एक तो चंडीगढ़ में है, करनाल में है. Every Tata showroom which is there on GT road from here till Jalandhar has a charger. So it's very easy for me to just stop for literally 30 minutes because generally average on GT road at about 80 km per hour 200-210 गाड़ी दे देती है. तो मेरे लिए ये इम्पोर्टेंट था कि मैं 15 मिनट कहीं रुक कर चाय भी पी लूँ, मेरी गाड़ी भी चार्ज हो जाए और मैं घर पहुँच जाऊँ सेफली.
We are right now 600 plus chargers, which we will become 2,000 plus by the end of the year.
A reliable and readily available charging network will bring down one of the key barriers in mainstreaming electric vehicles in the coming years. But what exactly does the coming decade hold for EVs for India? Tata Motors is on a mission to mainstream electric vehicle technology in India, helping the country evolve to electric. This is in line with India's ambition to drive EV adoption by 2030. As per these targets, 30% of all private four-wheelers sold in 2030 will be electric.
Just imagine today, overall, you have less than 0.1 million vehicles in the country today, right? So for that 0.1 million vehicle to become 30% of the total sales in 2030, roughly what we are saying is we'll have to maintain from now on annually a sales level of at least 45% of the new sales.
How can India reach this target in the coming decade? What are the factors that will affect this growth? First, consumers need choices. Another key factor is the cost of buying and operating an EV compared to conventional vehicles with internal combustion engines. Tata Motors believes that government incentives will play a key role here.
I must acknowledge that the role of these policies have been crucial in terms of raising the interest among the ecosystem players and also raising the interest in the consumers, which is even more important.
Batteries contribute to 30% of an EV's cost. Therefore, reducing battery costs is critical, something that is already happening rapidly. The battery prices have fallen from $1,120 per kilowatt hour in 2010 to $137 per kilowatt hour in 2020. That's an 89% drop. Falling prices of technology, combined with government incentives, is already reducing the total cost of ownership of an EV as compared to its ICE counterpart.
मेरे 6 महीने हो गए, almost 6.5 months. I have run 15,000 kilometers. At this point, I've saved 1.5 lakh rupees just on diesel जो मैं अपनी पुरानी गाड़ी में डालती. तो अगर मैं even 3 years down the line देखूं, तो I've already saved 9 lakh rupees. That is a huge amount.
In a country like India, the customer seeks vehicles that strike a balance between aspiration and affordability. As EV prices fall, customer confidence in the new technology grows, and the infrastructure to charge the vehicles becomes robust. India will reach a tipping point where the transition towards electric vehicles will become inevitable.
We are planning to bring EVs, which is the right balance between technology features price, and the driving range. This is the balance that we are trying to bring so that EVs become a mainstream choice in the country.
The future is going to be quite exciting, quite bright.
The story of the Nexon EV is a story of how one kickstarts a revolution, a once-in-a-lifetime transition that's shifting gears for the entire transportation sector, helping the nation evolve to electric, strengthening its economy, protecting our health and our environment.